Alright, so today I'm going to be implementing the midpoint ellipse algorithm. Been writing about the circle algorithm, the line algorithm, and we really need an ellipse algorithm to complete our collection. Been using CodePen. See at the top, creating an account as release assembly, connect it to a lot of other. I have mine connected to my Google account. But so let's get started. I'm going to base it off of my last CodePen here. So we create a new one, control click, but then I want to copy from my circle code. I'm going to have to streamline this at some point, but copying and pasting is working for me for now. And that gives me all the JavaScript and CSS necessary to get us a simple pixel display. So we're going to call this midpoint ellipse algorithm. So, gotta figure out how we're going to implement this. And I am relying on other websites to teach me how these algorithms work. I don't have them all memorized. You can see the Geeks for Geeks midpoint ellipse drawing algorithm. It's basically going to read through that and implement it. And see ellipse function right there. It kind of makes sense. It makes enough sense. What I'm looking for though is something more like pseudocode. And this one actually has it in JavaScript. Executes the algorithm and then writes all the points to the screen. So I'm wondering if we might be able to use that and then implement it, like replace the document.write with our own command set pixel functions. So let's give this a try. Take all of this and dump that into our program. Want those parameters. Rx, Ry, Xc, Xy. That defines our parameters. Want to use a slightly different syntax here. Let instead of var, so we're dumping more global variables into our scope. And all be on one line. Really, I'm just kind of cleaning up the code now. Points based on 4-way symmetry. Circles have 8-way symmetry. Ellipses have 4-way symmetry. And a lot of this math is based off of the standard equation for a circle, which is like a, right out here, it's like a x plus dx squared plus y plus dy squared equals r squared. And there's some amendments you can make to that to modify the size of the x-axis versus y-axis, which is part of what you're seeing up here. But I used to have all that memorized back when I was in high school, but right now it's just enough to know that the math works. Print points based on four-way symmetry. We'll come back to that. So what we need to do here is actually plot those points instead of printing them to the screen. What was our format for colors? We actually have a color object. And once we get the outline working, I'll see if we can get it to fill in the ellipse also. Alright, so that's those 4 points. And I betcha these 4 points down here are similar. X and Y are positive, X is negative and Y is positive, X is positive, Y is negative, and they are both negative for the last point. A lot of this theory is very similar to the line drawing algorithm, the way it just kind of walks around the edge of the circle, trying to see if it's like greater than or less than the value of the circle equation. Let's try this. In place of draw circle, we are going to draw an ellipse. And we'll start with just having the radius the same for both. So that should just draw a basic circle. If they have the radius the same for the x-axis and y-axis, you have a circle. But if we say that along the y-axis the radius is half, and there you go, it squishes it by half. Very good. Now, change it along the x-axis, just to make sure it works. So there you go. Now, want to get the flood fill working. Copy the parameter from our circle function. Now, what we need to do, the way we handled filling in our circles is like this. Setting pixels along that horizontal line, we're going to do something similar up here. And only 2 of those. actually xc minus x to xc plus x. I think we can actually get away with doing this. Let's find out. We're going to do this for both. And then down here in our render function, we can take the blinking parameter from our circle, and there you go. We have a blinking ellipse. Let's see if we can animate the radius a bit. Got the total time, so it's wiggling a little bit there. That's too much. Well, it's too fast. Let's divide that by 2. That should make it go half speed. Still too fast. I'm going to keep doubling this until total time divided by 32. Okay, that's starting to look a little slower. Okay, now we're getting somewhere. And I'm actually going to do the same along the y-axis, but use cosine instead of sine. That's fun. Alright, I'm keeping that. But we divide that by 2 so it stays on screen. And there we go. We have a relatively interesting ellipse drawing demo. And all of these functions are going to end up in the Electron project I'm working on. And you're welcome to follow along with that project if you want to see what direction that is going. And that is it for now. To be continued.